if we're dealing with a closed system, energy is always going to be conserved. So if we're dropping an object, it'll start with gravitational potential energy because something is holding it up, but if it's dropped, it will gain kinetic energy, and when it no longer has any gravitational potential energy, it will be at its maximum kinetic energy if these are the only two which we're worried about in this system. So, for example, if we have a 2-kilogram object which is released from rest from a height of 3 meters above the Earth's surface, we're trying to find how much kinetic energy the object has when it reaches a height of 1 meter. So this is problem 11 on the AP test. So what we can do is set up an equation. So in the beginning, it has no kinetic energy, so its gravitational potential energy is equal to mass times gravity times the height, so mgh, and in this case mgh is just going to be the mass, which is 2. Gravity, we can just use that as a constant for now and deal with it later, and then times 3 meters. So this. And then this is going to be equal to all of the energy at the height of 1 meter. So here it will have some gravitational energy left because it's still 1 meter up, but then it'll also have kinetic energy because it's been dropped, and some of the gravitational potential energy it previously had has been converted into kinetic energy. So to start with the gravitational potential energy, it's still 2 kilograms, that remains constant, but now it's 1 meter above, so it's going to be 2 times 1 times g, plus the kinetic energy, which I'll just express with the constant k, because that's what this problem is looking for. So let's simplify this by isolating k. We're going to get k is equal to 4g. And in the AP test, g can just be subbed in with 10, so it's going to be 40 joules, and that's answer D, or E, sorry. So the answer is going to be 40 joules of kinetic energy at this point.